In the previous lecture, we have studied about multi-threading models and hyper-threading. Now the next topic that we need to discuss is about issues in threading. But before we go to the issues that we face in threading, there are two important things that we need to understand, which are the fork and exec system calls. Now, after understanding the fork and exec system calls, we'll be in a position to understand the issues that we face in trading. Now, I'll not be explaining the meaning of system calls because we have already done a lecture on system calls, and if you have not watched it, I request you to watch it so that you understand what system calls mean. Now, before we go into fork and exec system calls, let me also tell you that this fork and exec system calls are mainly specific to Linux space systems, and you may not be able to use it exactly like how I'm going to show you in a Windows space system. But here, since we are discussing about operating system as a whole, and since we are not focusing on a specific operating system, it is good to know how different things work on different operating systems. And also, if you are interested in learning in depth about operating systems, Linux would be a very good choice because it is an open source system, and hence you can see how it is written. And you can also modify it yourself and learn a lot from that. Alright, now let us see what are these fork and exe system calls and what do they do. So coming to the first one, which is the fork system call. The fork system call is used to create a separate duplicate process. So whenever a fork system call is used, a separate duplicate process of that same process from which it is called will be created. So suppose you are having a process running and you want to create a duplicate or an exact replica of that process. Then we use the fork system call. So if we are using a fork system called, a separate duplicate process, which will be exactly the same like the process from which it was called, will be created. But the only difference is that the new process that is created will have a different process ID. So the process from where we call the fork is known as the parent process. And then the duplicate process that is created is known as child process. So as I said, this is an exact replica of the parent process, with the only exception that it will have a different process ID. Alright, now let's go to the next one, which is the exec system call. In this exec system call, what happens is, when an exec system call is involved, the program specified in the parameter to the exec will replace the entire process, including all the threads. So unlike the Fox system call, when you call an exec system call, or when an exec system call is involved, then we have to pass into this exec system call a parameter, which will be another program. So when we pass a program into this exec as a parameter, then that program will replace the entire process from which this exec was called. We can understand in simple terms that exec system call is used to replace a process with another process, and then they will have the same process ID, because here we are not creating a new process, but we are replacing an existing one. So the process ID will remain the same, but the contents will be different. So that is what this exec system call is used for. No, we don't want to simply learn this definition, but let us try to see and understand how this fork and exec system call actually work. So we'll be writing programs for this in C language, and then we will run it, and we will analyze the output, and we will see how this fork and exec system calls work. As I told you in the beginning, these are specific to Linux systems, so I will not be able to show you this in Windows. So let me just switch over to my Linux system, and there we'll be writing the program, and we will see how this to system course work. So here I am on my Linux system, and I'm using Linux Mint. And here I have created two folders on my desktop called fork and exec. And inside this folder I have written the programs where we will be able to understand how fork and exec system calls work. So coming to the first folder here, I have a file called fex1.c. This is a file in which I have written a program in C language. So let us open that up. Alright, so here this is a simple program where we have declared a main function, and then we are just printing one line over here. So the line here says hello, Nesto Academy, and then it says PID equal to, and here I've used a function to get the PID. which stands for the process ID. So what this program will do, it will just print hello Nesto Academy and reprint the process ID of this particular process that will be running. So now in order to run this program, let me go to the folder where this file was created, which is this for folder. So let us open that up. So now here we need to open the Terminal of Holiness. For that we just right-click and click Open in Terminal. And then the terminal will open for that particular folder, which is IndexedUp, and folder is named Fork. Now in order to run this, we type gcc space the name of the file. So gcc is the compiler that is used in Linux in order to compile C programs. So we type gcc followed by the name of the file that we created, which is fex1.c, and then you press enter. Now when you press enter, this file is compiled and the output, or the executable file, would be generated. Now if you look here, you see that there is a file called a .out. So in the beginning, we only had fex1.c. Now when we compiled it here, this air.out file is created, which is executable or the output file. Now we need to run this output file in order to get the output. So let's come back to the terminal and do that. So in order to run it, what we have to do is we have to type ./air.out. So that is the command that we use. And when we run it here, we see the output, Hello Nesto Academy, and the process ID is printed. So that is the output of all program. So that's all we did. We just printed Hello Nesto Academy, and the process ID is printed, which is 5824. Now what we'll do is we'll go back to the file, and let us edit that program, and put the fork system call into it, and see how it works. Now we come back here, and I will type a fork system call here. Alright, and then let us save this program. Now after saving we have to go back to the terminal, and we have to run this program. So we come back to the terminal, and in order to run the program, we type the same command, gcc file name, and we press enter. And then the output file would have been created. Now if you look at this, in the folder, there is a .out file. Was already there in the beginning. Now this .out file, which is here, now this is the new .out that was created and replaced. Now we are going to run this .out in our terminal. So we come back to the terminal and type the same thing, ./.out. And here you see the output. It is printed, Hello Nesto Academy with ID 5837. And again it is printed Hello Nesto Academy with ID 5838. Now you see that the program was executed 2 times. And why is that? That is because of the fork system core. So if you look here, we type fork over here, and when we type this fork, what happened was, this program created its own child process. That means this process was executed 2 times. Once by the parent, and another time by the child. So when this fork was used, Hello Nesto Academy, with the first PID, which was 5837, is printed, and then the child process was created because of this work. And that also got executed, printing the same thing, Hello and Academy, with a different process ID, which is 5838. So you see that the process IDs are different. So that is what I told you in the beginning, that when the fog system call is invoked, it will create a separate process with a different process ID, but the contents will be exactly the same. So that is where the same thing is printed, but just not to show you the process ID. I put this PID to make sure that they are different. Now let us do some modifications and try to find out. If I come back to this program and insert a few more folks, let's try to see what would be the output. So here I'm coming, and I'm typing 2 more folks. So here now, we have a total of 3 fork system calls. And I have saved the program. Now if I have this 3 fork system calls, what will be the output of my program? Let's try to find it out. So we come back to the terminal, and we compile the program, gccfex1.c. Now, before I run this, take a moment to pause this video and think for yourself. How many times will the print statement be executed when I have given this? For 3 times. And then we'll see if you got it right. Alright, now let's try to run the program again. So we type ./.out, and let's see how many times is it printed. Okay, so here we have our output from here. If we check, this is where we ran it, and it is printed 1, 2, 3, 4, 5, 6, 7, 8 times. So when we put 3, 4 system calls, it was executed 8 times. And in all of the 8 times, It is having a different process ID. Here it is 5850, here is 852, here is 551535, 75654. It is having a different process ID at each of the times. Now can we understand why is it printed 8 times? So first of all, what happened is that we have the first parent process, which is B1, so let me call it B1, which is the first parent process that is there, so it will print Helena's Academy with its PID just one time. So that is what it will do. So that is the first process that is there. Now when this first fork was executed, what will happen is this process P1 will create its own child process, and let me call it P2. So B2 got created, and now there are 2 processes. Now what happens is, when the second fork system call is executed, then we see that there are 2 processes. Now in our system, there will be child process created for each of these 2 processes. So for P1, it will create another child process. Let's call it P3, and for P2, it will create another child process, P4. So we have a total of 4 processes now. And now when the last system call, or 4, is executed, what will happen is, here we see there are 4 processes now, and for each of these 4 processes, there will be 1 child, each created. So let's say, for this B1, it will have another child process called P5, and for P2, it will have another child process. Let's call it P6, and then for this P4, it will have another child process. Let us call it P7. And for this P3, over here also, it will create 1 child process. Let's call it P8. So these are the number of processes that will be created. Now there are no more system calls. And how many are created? 8 of them were created. And that is why Hello Naso Academy was printed 8 times in this output. So here we see, for each of the times, it is having a different process ID. So the thing is, they are all new processes, but the contents are the same with different process ID. So that is what happened when we use the fork system call. So I hope with that it is clear to you how the fork system call works. Now let us go to the next one, which is the exec system call. Now I will come back to the next folder that I have created, which is the exec folder, where I have returned to programs in order to make us understand how the exec system calls work. So let's go into that and see what does it do. So as we enter this folder, we see that I've created to C programs, ex1.c and ex2.c. So these are to C programs. So let us see what is inside these programs. So inside the first file, which is ex1.c, here I have written a small program where there is a main function with some arguments, and then here, inside main, I have printed the PID of x1.c. That means the process ID of this program will be printed. So here PID of x1.c is equal to, and I am using the function getPID to get the process ID from the system. And here I have declared a character array, where I have put in the words hello, Naso Academy, and the last one is now. And after that, we are using the exec system call. So here it is written exec v. So there are different type of exec system calls within the family of exec. So this is one among them. And I'll not be explaining each of them separately, but just know that this is an exec system call. And here what we are doing is, we are passing as an argument the output of ex2 program that we have written. So ex2 was the next program that I have written. So this is ex2, so I'll be showing it to you later. Here I have written the output of ex2, and that is passed as an argument to the excc system code, and then is written here another statement, printer back to ex1.c and return 0. Now let's go and look at the next file, which is ex2.c, and see what I have written there. So coming to this ex2.c, here again similarly, we have a main function with some arguments, and here we have just written to printf statements. The first printer we are just displaying, we are in ex2.c. We are writing this so that when we enter into this ex2, this will be printed, and we know that we are in ex2 now. And then the PID of x2.c will be printed. Administer process ID of this particular program or process will be printed here using the getPID function. Now let us try to compile these 2 programs and run just one of them and see what happens. So in order to compile these two programs, what we have to do is we come to the folder where they are present, and then we right-click and open the terminal. And then we have to type the same thing. That is gcc space, the name of the file. So the first one that we're going to compile is x1.c. One thing that you have to keep in mind here is that when I showed you the previous program of fork, we saw that when we compile the programs in the GCC compiler of what Linux, it does is it will create a default output file with the name a.out. So a.out is a default name of the output file that is going to be created. But here in this case, we are going to compile two programs, ex1.c and ex2.c, and since they are residing in the same folder. So here what will happen is that if I specify a different name for the output files of these two programs, when I compile this ex1.c, it will create a default a.alt file. After that, when I compile the next program, which is ex2.c, then the output file that is generated for that is also named a.out. And that will replace the first a., or which is created by this ex1.c. But we don't want that to happen because we need these two programs. So in order to do that, we have to specify the name of the output file. Specifically, we have to type -0, and we have to just specify a name. Like I have done here, this ex1 is the name of the output file that will be generated for ex1.c. Now similarly, we can do for the next one. So ex2.c. and -o ex2. Here what happened, I compiled ex2.c and output file. I have specified the name as ex2. Now before we run this, come and take a look at this first file, x1.c again. So here what should be printed? The ID of ex1 should be printed. Then here we have declared Hellenus Academy, and here we are invoking the exe system call, and as a parameter or argument, we have passed the output file ex2. That is output file of the second C program that we have created, and then it prints back to ex1.c. Now let's see what will happen when we run it. So we type // and the name of the output file is ex1. We are just going to run the first one now. See what is the output. So we move it here, and let us closely examine what happened when we executed ex1. So ex1 is the output of this ex1.c. So here what happened? It came here, and it printed the BID of ex1.c, which is equal to 5962. So it printed this line over here. Then here we just declared this character array. And then here we invoke the exec system core. And what did we pass as an argument? x2, which is the output of the second program, which is x2.c. And then let's see what happened here. We are in x2.c now. Now, why did that happen? Check this x2.c. Here we are in x2.c. It is written. We are in x2.c. We are in x2.c. So we see that from the first program, when we invoke the exec system called, it jumped to this program. Right, and then it printed. We are in ex2.c, and then the PID of ex2.c is printed. What is it? PID of ex2 is 5962. So basically, what happened? It did not jump. What exactly happened was that when we call the exec system call, the content of the first process was replaced by the second process. So that is why, after the first line, these things were printed, which is a content of this second program x2.c, and if you observe it, we see that the PID, or the process ID, remains the same. So when we were in the first program, the process ID was 5962, and when we are in the second program, the process ID is still 5962. So we see that the process IDs remains the same. Exec system call will replace the contents of one process with another process. So it is not creating a new one. But the first one is replaced by another one. That is why the process ID is the same. But the contents are now replaced. We only executed one of them, and from that, we came to this. So that is how exec system call works. Now we come back and look. This first program x1.c. We see that there was one more line to be printed back to x1.c, which is not printed in our output. Why is that? That is because when we enter this x2.c in this second program, we did not specify anything for it to go back to the first program again. So it never had the control to come back to this first program again. So that is why this portion is not printed. So that is how exec system call works. It replaced the contents of the process with another process. So the processes have the same process ID. That means the same process, but the contents are replaced. So with that, I hope it was clear to you about how fork and exec system call works. So fork will create a separate duplicate process, which is a child process with a different process ID, but the contents remain the same. But in exec system call, it will replace the entire process, but the process ID remains the same. So that is how fork and EC system call works. So if you understood fork and EC system calls, we can now move into the issues that we face in trading from the next lecture. So I believe that by writing the program and running it and seeing the output, we were visually able to understand and visualize how the fork and exercist system core works. So I hope this was helpful to you. Thank you for watching and see you in the next one.